But the first quantity I introduced in circular motion is angular velocity or angular speed. So that is defined as a change in angle over change in time. Now we call the angular displacement of time. That is the definition of the angular speed or angular velocity. If you take the time to be period means the time to complete one circle. Then angle, the object moves, it will be 2 pi radian. You have learned about the radian in core math. 2 pi radian. You have learned radian in core math. But the unit for the radian is the unit of angular speed is radian per second. And the second equation you have learned is the V R omega. That's how we relate the speed and the angular speed together. It's the radius times the angular speed. But for the proof, you just go back to the notes yesterday. The last thing we talked about yesterday is the centripetal oscillation. So there are two forms. What you need to remember is for any circular motion, the oscillation will have the magnitude, that's V squared for R or R omega squared. Yeah. No. I said that you don't need to know the proof if you don't understand it. No need to know the proof. It will not be in your exam.
So if it comes up in an exam, it's acceleration?
Yeah. R is the radius. Microphone. The next part is let's go to the next chapter. And also I told you in the yesterday's video, in most of the case, the exam, the long question in exam will combine these two topics together. So first of all, let's talk about the gravitational force. Now we have a formula for that. It's the big G mm over R squared. Now the big G is called the universal gravitational constant. No. Mm are the masses of the two objects. R is a separation between these two objects. Red. Ooh. Now in your calculator to find this constant, shift 7 and then 1 7. Shift 7 1 7. Then you can find this value. But there's some unit here. But the unit will be like very complicated. But if you want to write it down, it will be like. I just derive this unit from the equation. You can also derive it by yourself. So small m and big M are the masses of the two objects. And R is the distance between these two objects. Now for long question, it will ask you, it will ask you to state the law of Newton's law of gravitation. That means they ask you to write this formula in wording. So you will write that you write as the force is proportional to the product of masses.
What is that? The two arrows and an arm is
The distance r, and inversely proportional to the distance squared. Newton's law of gravitation. I'll give you a summary for those wording questions that you need to remember. LQ, long Q, long questions, long question. And that means paper four. Most likely it will be 1 mark or 2 mark. It seems this form is not difficult, but now let's move on now. But remind that for this formula, these two objects should be 2 point masses. That means these two objects should be a point. In other words, that means if these two objects are not a point, you can't use this formula. Then it seems that this formula is useless because no object is a point. But actually, Newton has, Newton invented the calculus. He made use of calculus. He used 10 years and showed that he showed that this formula can also apply for a sphere. Solid sphere. So you still can use this formula for two solid sphere objects. So let's give you an example. Let's say for the Earth and the Sun. Okay. But for the R in the formula, we should measure the distance from the center of the Earth to the center of the Sun. For R. Okay. So the distance between the Earth and the Sun is 1.5 times 10 to the power 11 meter. The mass of the Earth is 5.98 times 10 to the power 24 kilogram. The mass of the sun is 2.0 times 10 to 30 kilogram. You don't need to remember it, okay? It will all be different impression. So can you find the force between the Earth and the sun? Find a gravitational force between the Earth and the sun. But in this first part, you deal with the numbers. You deal with very large numbers. You try to use your calculator. Have you got this answer? Angular speed. Angular speed. I write it down over here. Mm. 最尾咁慢嘅。
Sir, why isn't it just d squared? Why does that
What do you mean by d squared r squared? Just a symbol. Don't ask me why. I use that symbol. Then don't ask me why it's used in R. Then you do the research by yourself and submit it by the end of August. Do you have math error?
Pretty sure I'm using the calculator wrong.
Được rồi.
It's 6.67.
O2. Okay, for this, so that's a formula for the gravitational force. Have you all found it? But let's take another example. I think you know about my mass. So my mass is 45 kilograms. That's my mass, okay? But the radius of the Earth is 6378 kilometer. So can you find the force provided by the Earth on me? On me by the Earth. So this is between the Earth and the Sun. So that's between me and the Sun. And the Earth, okay? And the Earth. No. Yeah. So you get 441 Newton, 441 Newton. If you find it from 45 times sine of x1, it will also give you the same answer. I hope you still remember what does it mean by the mass times g. It's the weight of, it's my weight, okay? Yeah, you still get the same answer. Because you know the weight is just the gravitational force by the Earth. So they will give you the same answer. Okay? That's on me and the Earth. Gravitational force. We are just talking about gravitational force. That's a formula you have learned it in Form 5. That's the weight. Is it? They're equal. They're equal because you know gravitational force is the weight. So this is the force, gravitational force between the Earth and the Sun. Why I say between? Because first of all, you need to know. The question may ask you. Now you know there's an attractive force by the Sun on the Earth, but at the same time, the Earth is also attracting the Sun. These two forces have the same magnitude because acceleration pair. Now you write down, okay? Now F1 and F2 they are equal because of the Newton's third law. They are acceleration pair. They're the same magnitude. So you can see that the Earth is pulling me with the magnitude 441 Newton. And actually, the Earth is also attracted by me with the magnitude 441 Newton. But for all the objects on Earth, we normally just count the gravitational force by the Earth because you are not attractive, okay, to me.
Sure, are you sure?
Yes, the attractive force between you and me is so small. Okay.
So small.
Huh? That's my race on Earth. mg, do you still remember the formula mg? I just want to show you they give you the same magnitude. Because the weight is just a gravitational force by the Earth. Only when this object is on Earth. I'll talk about this later on. Really. Well, then let's go to the planet and the sun. Which object is at the center of the solar system? The sun.
Well, I thought the Earth is so special.
Then you go back to study high school. So this is the Earth. Good. This is not the top view, okay? Now let the mass of the sun be the big M, the mass of the Earth be small m. Now we know that the Earth is orbiting around the sun in a circular orbit. And also we want to, the only force acting on the Earth by the sun is a gravitational force. This is only force acting on the Earth in the universe. Now we will ignore the force by the Mars, by the Venus, by Mercury on Earth. We just count the gravitational force on Earth by the sun. And because this is the only force acting on the Earth, so this force is actually the net force acting on the Earth. Okay. This is the only force. That means the net force.
What about Earth? Sir, I'm trolling.
Yeah.
It was a joke.
So we'll write it as E or MA, is it? And because you know this is a circular motion, the acceleration can be written as V squared for R or R omega squared. Then you can write it as mv squared for R or mr omega squared. Now, this is always the step you need to do in the long question. Relate the gravitational force to mass times the centripetal oscillation. In short, it just write it the gravitational force equal to the centripetal mass times V squared for R. So your job, can you make the V be a subject of the equation? Make V be a subject of equation. Okay. So I also want you to derive another formula. So because you know omega, the angular speed can be written as 2 pi over period. Is it? Oh. So can you make the period square be a subject of the form of the equation? You make period square be a subject of equation. You expand it by yourself. Don't be lazy. You'll be asked in exam. That's one exam question.你做咩？你想做乜？你10點就瞓咗咯喎！我11點先，我12點先瞓，然之後4點就起咗身啦。係。
How do you know which one's smaller?
It doesn't matter. You but because we are talking about the left now, why this one is small m, okay? But this here is doesn't matter, is it? Just a product of small m, big M. But why here is a small m here? Because you're talking about the small m is moving in a circular motion, not the big M. So here should be small ma. Okay. Have you done it?
Wait, so is big M usually the stationary element?
Yep. The big M is always the larger mass. This, I'm always a small m, okay? Now, like,
How much do you weigh?
45 kilogram.
How do I weigh times the power 10 to the power.
So this is a formula. Actually, it's a very famous formula. Now, this formula has another name for it. We can also call it the Kepler's third law. But you don't need to learn about the first and second law. This is the third law. Actually, you don't need to know the name. But they will ask you to derive it by yourself. Like you have learned how to derive it, is it?
Okay, so this is a dumb thought. When there's a fraction under a fraction, the bottom thing goes to the top, right? Yeah.
Yes. Now then let's take a look at this formula and see how we can actually get the mass of the sun from this formula. Let's switch. Hold on. Now from this formula,
So what's the formula called?
you don't need to learn about the name. Just ignore it. So if we're talking about the Earth orbiting around the sun, the big M should be the mass of the sun. The big M should be mass of the sun. And then T will be the period. So what is the period for the Earth orbiting around the sun?
1 year.
1 year. Yeah. And remember, you need to convert it to second, is it? And I'll give you the R. That's the radius of the circle. So that is 1.5 times 10 to the power 11 meter. So can you find M from this equation? You know how to convert year to second, right?
Yeah.
Yeah.
Sure. Should I test it after?
I don't know. After you have done it. You do yourself?
Oh, you just
1.5 times 10 to the power 11.
So do we need to remember
And
what
it's
GCE
square.
is?
The big G is a constant given in a formal sheet, and also in your calculator.
So the force changes depending on leap year.
The force change depends on what's the period.
Wait, sir,
Wait, so why is there a
1 times 10 to the power of 26?
Now here is cube bar, r cube bar, this t squared. T squared, r cube. Hmm? Have you done it?
Doesn't matter where you take the angle, like so, like in your example, Jen and Alston, it doesn't matter where you take the angle, you just kind of change it. Wherever it is.
So it's around, I think in the calculator you get 1.99 times 10 to the power 30 kilograms. You get it? Now, this we substitute the values for the Earth orbiting around the Sun. So let's take a look at another. So let's say if this is Mars. You know Mars also orbiting around the Sun. So now for the radius, that's another unit for radius. It's called the astronomical unit. Have you learned it? Now, astronomers like to use this unit because they set the orbital radius of the Earth be 1 AU. 1 AU. 1 AU. Astronomical unit. 1 astronomical unit, that means the distance between the Earth and the Sun. That is 1.5 times 10 to the power 11 meter. They just convert this unit to 1 to make it simpler, it seems. The distance between the Earth and the Sun is 1 AU. Yeah. So you know the period of the Earth is 1 year. Is it? So let me give you the orbital radius of the Mars orbiting around the Sun. It's 1.5 AU.
Sorry, at least you can.
And I would like you to find. I would like you to find the period of the Mars. Find the period of the Mars. So how can we make use of this formula? Now you know the Mars is also orbiting around the Sun. So the 4 pi square over GM are the same for both Mars and Earth. Is it? So we can write as t squared is proportional to r cube. Because 4 pi square over GM is a constant. 4 pi square over GM is a constant. So then, for all the planets, how many planets are there in the solar system? 8. For all the 8 planets in the solar system, still 4 pi square over GM is a constant. That means T squared is proportional to R cubed. Then we can write it like the period of Mars divided by the period of the Earth square equal to the radius of the Mars cube divided by the radius of the Earth square cube. So can you find the period of the Mars? Now you don't need to convert the unit back to second. You just keep using the unit AU and meter, and year. Because the unit can be cancelled out in this formula. The unit can be cancelled out in this formula. You don't need to care. You don't need to change it back to meter and second. And this one is actually pretty simple. So 1.5 squared divided by 1 squared equal to the R. Oh, sorry. So the period of the Mars square divided by 1 square will be Rm cubed divided by 1 cube. Then you just substitute the values. Then you get the answer 1.8 year. You get it? Hmm?你點計出嚟㗎？你攞過嚟先，你攞過嚟。你分子份冇望清楚啦，你代嗰陣啱唔啱？Any questions here? Huh? For Sweeney.
So are we finishing this chapter today?
By tomorrow.
By tomorrow. So is it just one of the 5 into that one question? How many chapters?
So this is 1, is it? 1 year. This is 1 AU. This is 1.5 here. You want to just find a TM. Now you know how we derive this formula because 4 pi square of GM is a constant. So we can write T squared is proportional R cubed. You learn it in Form 4 RGCSE math. You have learned about the variation. You did. Proportional, you have learned about that. You did. Hmm?
No,
So isn't it 1.8 something like that?
So then you can find that the period of the Mars orbiting around the Sun is 1.84 or 1.837 year. Okay. So there's some questions something like that in the past paper. Now let's take a let's take a 5 minutes break. I've given some exercise after the break. Yeah, the long question one. So let's say 1A, you just answer as the gravitational force is proportional to the power of the mass and inversely proportional to the distance squared. Okay? You don't need to write down, don't waste time. Now part B, can you see that they ask you to show this formula yourself? That's why I have taught you how to derive this formula. If you don't know how to derive this formula, then you lost 3 marks. Okay? Although they use different symbols here. Oh? Yeah. You see, go back to C. We have derived it before, ma. Today. Just today, you are. My mx and then omega square. And omega is 2 pi over p square. Ma. Then blah, 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 and then you can get this formula.
That's all you have to show.
Yeah. You need to show more steps, okay? Not just write down the final answer. GM over x squared is a gravitational force, the formula. 你自己中意啦，你總之整到嗰條式咪得咯。我唔理你，你乜嘢做 subject 啊 ？That's another name for this law is called Kavas law。係 this one 咯，冇分別㗎。你 subject 唔同啫嘛，有咩分別啫？咩啊？你個 subject 唔同咧，有咩所謂啫？連 formula。你 F 等於 ma 同 A 等於 FOM 有分別啫？咁你將 GM 做翻 subject 咯。咁佢中意用 GM， 佢咪用 GM 咯？你嚟得人哋中意啲乜嘢啫？係咪先？去 relate with this formula 嘛，即係叫 show this formula 咯。喂，叫 show 呢條 formula 啊嘛，你明唔明條題目問乜嘢啫 ？The question asks you to show this formula 啊嘛 ，it's not given 喎 ，you show it in the last step 喎。Then 你完全唔明係。You are not given this formula and need to show this formula。係咯，跟住點啊？咁 I told you, you always need to relate the gravitational force with ma. A can be written as v squared of r or r omega squared. Then this is always your first step for questions. And then you just explain it and then divide and then do it by yourself and then get the final answer. Hi. That's what we have done before the break. You have any question? 唔難啊嘛呢個 ，just quite standard. We have just done it once 啫喎。有咩問題？ Can we move on？ 咩啊？你先，你講一次聽唔到。你講一次，你講一次好冇 ？What do you mean by it's not the same as that one？ You just change your subject 啫嘛。What I show is t square equal to 4 pi square over gm times r cube. You just change the subject, you can see they are the same. They just use the distance as x 等於 x 咯。你唔識 change subject 咩？咪先？個問題係咪你唔識 change subject 先？咁你係咪證明唔到呢條同呢條一樣先？定點樣？你個問題係邊度先
So why did you do n times w squared?
mx omega square。
Oh,
呢度有咩問題先？係咯，咁一樣啫，兩條式。我有 derive 過㗎，冇分別嘅兩條式都係叫你 derive for chemistry 咯，有分別咩？嗱 ，so can we move on? And then I give you this diagram. Sorry, where's my mouse?
that question is true.
Yeah. So and then this one is a planet with its 8 moons, Neptune, and then each in a circular orbit, and x and t is given. Now you have derived that formula. So in this diagram, it's x cubed against t squared. So we should put to find now when you see this kind of diagram, you need to think about two things. One is area and one is the slope. Now I think you can see that from the formula. You have something like x cubed over t squared. So that is gm over 4 pi squared, is it? So that means the slope or the gradient of this graph is gm over 4 pi squared. Understand? But the problem for this question is the unit. The unit is not SI unit. One is km cubed, one is day square. One is km cubed, one is day square. So I would like you to do it yourself. So you need to convert km cubed to meter cubed, and so also convert the day square to second square. So 2 minutes time. Now, first of all, do you understand why the slope is equal to gm over 4 pi squared? Because it's x cubed over t squared. X cubed over t squared is the slope of this graph. Then you first of all you find the slope of this graph. Now I make my graph larger. Then I find 2 points on the graph. Yeah. Let me find this one and this one. So the slope should be 你自己寫咯，自己 derive 啱啱寫咗出嚟㗎。咩啊？ So it's 4.5 minus 1.3. Now you do yourself, use your brain. I've already asked you to bring your brain to the school. So divide by 0.35 minus 0.1. That's it. But this is not in SI unit. That's the mass of the. Now, in this case, are the moons orbiting around the Neptune. The Neptune is the larger mass. So the big M should be the mass of the Neptune. We need, I didn't do it yet. Oh. Now, kilometer to meter cube, you still remember how to change it? Yeah. Or times 10 to the power 3 to power 3. So make sure you all know how to change km cube to meter cube. Otherwise, many of the questions you will GG.
Sure. How do you get the value?
What do you mean how to get the values? Just use your calculator.
GM.
Just a second, okay? Now day square to second square. So 1 day is 365. Sorry. Now 24 times 60 times 60 and square. So this value equal to GM over 4 pi square. Then you just get the M from this equation. Because it just changed the km cube to meter cube. Like for example, your 2 kilometer cube is not equal to 2,000 cube 㗎嘛，係咪？你唔好 solve 你自己計啦，佢個數太大，計數機唔可以 numerical 幫你 solve 㗎啦，你唔好咁難啦。Let me see. Done it? Any questions? One. Right 左邊寫咗啦。唉，嗱出 cheat 啦嚇。You see it? So any question? Now you change kilometer to meter cube. You change days.
6.8.
Where is 6.8? Where?
For the range.
Whatever, I'll just get the final answer for you.咩啊？邊度啊？呢未學嘅我哋。係啊，我未學嘅。如果係有一半係點解？ 你中意咧？
點解咁樣樣嘅？我咁少咗，咁多咗少少。So are you finding M?
This is just a gradient 喎 ，it's not the M 喎。呢個 gradient 嚟啫嘛。
我哋 gradient。
係啊，個 gradient 啫嘛。
哦，即係
係啊係啊。1.0 times 10 to the power 26.
Why is this reciting number?
So it's not. You do the middle step.
Oh, the gradient. But the gradient is just 1.71 times 10 to the power 14. And then you times 4 pi squared divided by g, then you get the mass of the lepton, no? But you take too much time to do it, lah. You should really speed up, ga. Now this question is pretty easy, I think. Now, if you think about for just like for this question, 2-mark question, 2-mark for memorization, 3-mark for you to derive the formula. You have learned already. 4-mark is just using that formula to derive the mass. There's nothing else, is it, for this question? 9 marks already. 9% of your period 4.
I don't know how I got the gradient to be 6.8.
How many marks is paper 4?
100. Negative 11. Negative 11. Negative 11.
Yeah, no, but I messed up on the gradient.
This one is wrong. I think you multiple the 0 time. This is the
Wait, you square that first?
yeah.
You don't square
just
after you
change-
times that?
You go back. See, you go back first. You go back first. No. You go back first. You go back first. No. Now, there's many of you get some mistake. Now, let's say for this one, the day square is 0.1. Now, this is 0.1 day square here, is it? Now, it means 0.1 times 0.1 day square does not mean 0.1 day total square. The final. 0.1 day square or 0.25 day square is not 0.25 day total square. Because you get that mistake, so you get it wrong. We spend so much time on this question. Let's move on. Now go to the next one, the next question. Now we skip the first two parts, part A and part B. Just the same question, is it? Okay, you all move on to question 3. Question 3. Shh. Too noisy. Now let's go to part C directly. Part C directly, okay? Take a look at part C. Now, this data gives you the moon tier orbiting the N 啦， the moon O 咧 orbiting the U 啦。And then they want you to find the ratio of the mass of N to the ratio to the mass of U. Now we just use this formula, Now remember there's in total, here are 4 objects, 2 planets and 2 moons. So this moon orbiting around the Neptune. So, and then this moon orbiting around the Uranus.
Sir, what was the answer to the last
1.0 times 10 to the power 26 kilogram. Now then you get, now you need to use that formula twice. This formula. Now because they are not orbiting around the same object, they're orbiting around, these 2 moons orbiting around 2 different planets. So you write it as T squared equal to 4 pi squared over G. Now if you're using about the moon T, then this should be the mass of the Neptune. This is radius of the T, okay? If you're talking about the moon O, then it should be the mass of U and then the radius of O. Now in the question, you are asked to find the ratio of M, the next one. Now you are finding the mass of N divided by NU. You're going to find this ratio. So how can we do it? We just use the one equation divided by another equation. Then somehow by using some math, you can get some ratio, the ratio of the masses. Then you can try to do it yourself. I hope you can understand. For these 2 questions, the physics is not difficult at all. You just need to know how to derive this formula. It's just your math. You need to use your math to derive the mass or the ratio of the mass. You have the hard copy. You take a look at the next page yourself. Hi. The back is this one.唔知啊，未計啊。 You use one equation divided by another.
So is R in this case 1.5 times?
No, the 1.5 times that how you have is the radius from Earth to Sun. Is there any Earth and Sun in this question? Then
Yeah, we can put that. So the G is 6.67 times.
yeah, they are constant. You can cancel it out. Now, or another way around is you don't use ratio. Like you find the mass of Nm and find the mass of Mu from these two equations. And you do find the ratio. I just need to find a ratio, not find the I don't need to find the masses. I use a formula, I show you 咯。你要 show 俾我睇你個 step，我先知你錯啲乜嘢。你唔係知道我啱啲乜嘢，係你要知自己做錯啲乜嘢。你又唔 show 你。睇你用 soft 錯先。你個 mask 都計錯，上面兩個都計錯。
我總係有啲唔係太明點樣塞個數，即係有 power 嘅時候。
你就照心咯。
即係5.9 square 除13.5 square 咁樣。
係啊。
哦，咁。
點解？因為個 unit 一樣嘛。你係 cancel out 個 unit 噶嘛。
哦。
你係 day square 咪 cancel out 個 day square，所以唔使轉 second 再答佢。
哦。
係咯。係啊。
So if you show a graph of the velocity, is it a function of something orbiting something? Yes.
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 So yes. Yes.
Now, first of all, you need to understand these two formula. And then now I use the second one divide the first one. Now, are you able to show this one by your algebra? By yourself? Now, one question you may ask is how do we substitute the values? Have you get it? Have you get 1.18?
Wait, that's the ratio? put 4,000.
I won't understand why you get it if you don't show me your steps. T square. I'll cube. Do you cube it? Do you square it? And also, this is not meter. 3.55 is key times 10 to the power 5 kilometer. It's 3.55 times 10 to the power 5 kilometer. You need to change it back to meter. 1點幾啫？1點幾多啫？唔係，但係咗6點幾。唔係乜嘢6點幾啊？你話 mass？ Show me your step 啦。點解呢度要 cube 嘅？點解要 cube 先？唔係點解10嘅 cube 再 cube 先？點解之前要 cube 啊？你唔係淨齋死記噶嘛？你知道點解之前 cube 噶嘛？之前你應該要 cube 咗啊？上次嗰題，啱啱嗰題點解要 cube 咗佢？嗰個咩單位嚟㗎 ？K 咩乜嘢啊？呢度有冇 K cube 啊？係咯。幫我咪隨機嘅數，不過咧係啱嘅啦，係好。
For this, for t squared, do I square the days or do I square both?
Both the total t is 5.9 times this one 啊嘛，and t square is this one total square.
So why in the other one is?
That one is just km cubed.
Oh, so we are like, yeah.
We spent more than 30 minutes on these simple questions. How come?
This is why we're at summer.
I wasn't there for this.
Do you get 1.18? I think some of you are just finding the MN and MU separately.
Yeah, because it's easier.
No, it's easier to do it by just using a ratio. Can you see it?
No, I didn't.
How
use
different,
it.
how,
He's finding it from there. Just use there.
then, but just by using this one, then you can get the answer to be 1.18. Okay, let's move on now. Okay, so let's you can see another question, this one. So in question 8, it asks you to divide this one. Are you able to divide it by yourself now? We have divided it already, is it? In the note. Now we haven't learned something new. We're just so slow. Now let's go back to the notes, okay? And then let's move on. 係咩啊 ？break 咗咯喎。嗱。So we've talked about some question about the planets moving around the sun or the moons orbiting around the sun. So let's move to the satellite. I just let you to watch a part of the video first. We are going to talk about one satellite that is quite common, orbiting around the Earth. So that one we call the geostationary satellite. Geo means Earth. So that means this satellite it seems it moves stationary to the Earth. It seems it's stationary to the Earth. Actually, what it means, let me draw a perfect circle. Now this is axis of rotation. So this is equator. We learned about the equator yesterday. So those satellites can only above the equator. Let's say if you're standing on the equator, and luckily there's one geostationary satellite above your head. Then this if you do not move, then this satellite is always above you. It will all rotate at the same period with you. Just one day about the Earth.
So basically, it's all
Hmm?
So basically, all
Yeah. with the period 1 day as u. So now you may be asked about some properties of the geostationary satellite. You need to mention that the period is 1 day or 24 hours. And you need to mention that it should be only above the equator of the Earth. And also it rotates in the same way as the Earth. That means from west to east. Now there's one question here. Let me show you. So above the equator, period is 24 hours, orbit from west to east, and also only one particular orbit radius. Now from west to east, it means it follows the same rotational direction as the Earth. From west to east. And the last one is they have only one particular orbit. Now we are going to find the radius of this orbit. The radius is fixed. That's if you get a larger radius, it's not geostationary. Or you get a smaller radius, it's not geostationary. Now, same as the last question, or same as the previous questions. So in this case, the gravitational force is the only force acting on the satellite. Now the satellites are used as small m, the Earth are used as big M. Earth is at rest in this case. Earth is a larger mass. Okay. Then you can always write down this formula. Now it's either m is ma. It's either mr mu square or mv square of r. Now you may ask which one you should use. Now it really depends on what you want to find or what you have given. So in this case, actually, what you are given is a period, is 1 day. Then we use mr mu square. 你望住我做咩啫？你望住 screen 先有用㗎。Then the angular, that means you are given the angular speed. It's 2 pi over period, it's angular speed. Now I given that the mass of the Earth is 5.98 times 10 to the power 24 kilogram. So can you find the orbital radius for this satellite? Find the radius of this satellite. Now you simplify the formula a bit by yourself and then find the orbital radius. 聽唔到。The two small n can be cancelled out in the formula. Can you see it? The small n can be cancelled out in the formula. The small n can be cancelled out in the formula. It doesn't matter at all. Or you use a soft equation function. And it's always using the same formula. Actually, this topic is so boring. You are always using the same formula. 有幾唔同啲又咪同一條係咪先？咪又唔係嗰個科，又唔係你之前 divide 咩 t square over r cube 跟住 4y square over gm 咯。咁你計到未啊？點解你唔撳咧？ What you get? Yeah.